Video is on teaching the ultimate way to validate user input. So in order to learn how to do this, you first need to understand that input and output in C++ is all in a stream. So there's an input stream and an output stream. And so we use that IOStream class in order to do input and output in our programs. And it doesn't matter where we're reading from or what we're writing to, whether it be a screen or some text file, you still are using streams of data with input and output. There are stream states available in the iOS for C++. And these stream states are actually bits, or you can call them flags. So there's a good bit, which means everything is okay. There's a bad bit, which means some kind of fatal error occurred, like the program tried to read past the end of a file. There's a eofbit, which stands for end of file. So that's when the stream reached end of a file. There's a failbit, which is a non-fatal error occurring. For example, when the user enters letters when the program is expecting an integer. So if you're reading an integer with cin and the user enters in a character, remember what happens is that we have this buffer, and if they're entering it in from the keyboard, let's say, and they enter in a character instead, and of course they hit the enter key, what the cin object tries to do is it tries to get that letter and it tries to translate it to a number, an integer. And it's not able to do that, so this failbit is set to true. Now, as soon as the failbit is set to true, which I'm just going to write a 1 for true, that means that the good bit also changes to false. Now, by default, so before this happened, by default, the good bit is always starts at true, and the bad bit, eofbit, and failbit are always false. And so as soon as one of these becomes true, the good bit changes to false. And so that's how that works. So whenever you're testing a string to see if it's good or bad or whatever, if you can either test the good bit to see if it's good, or one of these other bits to see if something failed. If specifically, if you're looking to see if a user entered in something other than the data type you're expecting, then you can check this failbit specifically. Now, there are functions, member functions, in the library to test these bits and to actually access these bits. So the good function is testing the good bit, and the bad function tests the bad bit. For the EOF bit, we have the EOF function, and for the fail bit, we have the fail function. You can also, for the fail function, instead of saying fail, so actually let me back up. If you're wanting to test the fail function, for example, you could do cin .fail. And if you're working with the input file, you would put the input file name there instead of cin. And that's going to test if the fail bit is true for that, for this current stream, for this cin standard input string. If you want to say, did it not fail, you would just put a not logical operator, cin.fail, like that. You can also shorten this to just say not cin. So The same thing kind of applies to good. So let's look at the good functions. So, and by the way, these would be like in a while or an if statement. You know, these are conditions that's returning true or false. Like that. And so the same thing with the good function, we can test if cn.good, or if we want to check opposite, if it's not cn.good, and so you can also, whoops, I meant to put parentheses there, just say not cn. So actually just checking cn, you don't have to put good or fail. It will actually call those functions automatically. So let's look at the code. This was important to understand before getting into the code. Actually, let me change this up. So normally what we do is we say something like enter in a number, and I'm going to read that in to an integer called num. And actually for right now, I'm going to get rid of this validation loop. We'll add it in a minute. And so what this program does right now is it allows the user to enter in a number. We read that in with cn in our stream extraction operator, and then it prints out the number they entered. Then it asks the user if they want to run the program again. We read that into a character variable called answer. And then we make that a lowercase letter. If it's already a lowercase letter, it'll just stay a lowercase letter. But if it's an uppercase letter, it will be changed to a lower. And remember, this function is in the CC type library. And so it's going to check if it's yes, and then it will come back around. Okay, so right now we're not doing any validating of the user input. And just to run it real quick, we're going to run it every time I make a change. We'll run it and see what happens. Validate input example.cpp. My computer's kind of taking a long time to compile. There we go. So enter in a number. If I enter in an 8, it says you entered 8. Run again. I say yes, but if I enter in a character, that's going to crash the program. And so that's what we're trying to fix right now. You already know how to write a validation loop to check if a number is within a range. And we'll add that logic after we talk about how to check to see if they enter in a character. So the way to check the state at the same time of reading in the value is to actually put the read inside of the loop. And this is what I recommend if you are reading multiple values with a loop. You can do it this way. But what this allows us to do is it's going to check right now the way it looks. It will get in this while loop if we are able to read a number. But what we actually want to do is get in this while loop only if we're not able to read in a number successfully. And so this is where I'm going to put the not in front. But this is important. We want to make sure we read into that number before we check if it was able to do that successfully. And so I'm going to put parentheses around this, so to force this to happen first. And then if this did not happen successfully, it will return a false. Not false is true, which will get us into this loop where I can say, you didn't enter in a number, enter in a number. And I know usually we put another like CN statement here. But we don't need to do that this time because we're reading it in right here in the expression. It's a little bit weird at first to get used to. So what this will do is it will allow us to read in another number. There is still an issue though. So I'm going to save this and run it so you all can see what happens at this point. We still have to add a couple more things, but I want you to see what it looks like at this point. Validate input example. Oops. So enter in a number, just like before. If we enter a number, it works perfectly fine. Yeah, I can do it again. But this time, let's enter in a character. So it still didn't work. Still didn't work, and it's not going to. And the reason why is because what's happening here, let's see, I put in a C, I think. But anyway, I put in a character and a new line, and that went in the keyboard buffer. But it wasn't able to actually remove the C from the keyboard buffer. It did correctly flag the fail bit. So it is saying, hey, this failed. And so we're in an error state in our stream. And it never gets set back. So failbit is now, like at that point in the program, failbit is 1, goodbit is 0. And it's going to remain that way until I change it. So the first thing we have to do is this function called clear. We want to clear all flags and restore them back to their defaults, which means the good state bit will be 1. So to do that, to run that clear function, what I would do is I would do it right here in the wallet, because I don't need to clear the bits unless a fail bit was set. And so it would be cn dot clear, and it's empty brackets. Okay, so let's see if that fixes the problem. So I'm going to do exactly what I did before. We always want to make sure I didn't mess up the case where they actually did it correctly. But of course I didn't. I only made a change in that loop. So I'm going to run again, put a C, hit enter. Oh, we still have an issue. Okay, so what is the issue? Okay, the issue is now I've correctly set goodbit back to 1 and failbit back to 0. So that's not a problem. But that C was never removed from the buffer. So what's happening is that CN is now reading that C over and over and over and setting it back to failbit. And then it's clearing that bit back to goodbit, but then it reads that C again. We've actually got to remove that C from the buffer. So remember how to remove something with the buffer is a cn.ignore. And so cn.ignore. And what that does will ignore one character from the keyboard buffer. So let's see if that works. And for some reason, whenever you have this issue with the input stream, I can't do Control C to make the program quit when it crashes. So that's why I keep having to open up a new command prompt every time we're trying to recompile. That's one of the only times that you can't just force quit the program from running because it's in error state. Okay, so again, entering a number worked perfectly fine. Run again, C, hit enter. Okay, so this time it worked because I just enter in one character. It says you didn't enter in a number. And so if I do enter in a number, it works perfectly fine. That's great. But there's still an issue. So this code right here will work as long as the user only enters in a single character or symbol that's not an integer, or an integer. But what if they enter in a whole string, several characters? Well, it still works, but what happens is that it makes that loop iterate for every single letter, because at each time that cn.ignore is removing one letter at a time from the buffer. So it first pulled A, and that put the stream in error state. Then it cleared the error state, ignored out the A, so removed the A. But see, P, R, I, and L are still in the buffer. So then it says, you didn't enter in a number, enter in a number. But then it takes that P. Oh, P is in error state. So then it clears that, so it's back in good state. Then it ignores that P, takes the P out. But then it thinks that the user entered in the R. So you see, that's why it keeps repeating. So we need a way to remove more than just one character from the buffer. And so the way we do that is still with this ignore, but we're actually going to put something in these parentheses this time. So typically what programmers do is they put 10,000 here. And so this is going to remove up to 10,000 characters from the buffer, or until it sees a new line. So you actually need both of these arguments, a big old number, and this is what a lot of programs, like if you look up code to do this, this is what you'll often see. This will ignore up to 10,000 characters or until you see a new line. Okay, I'm going to save that, and I'm going to recompile this. This time I didn't have to completely start over, which is great, with the new command prompt. So we're getting better. We're improving this little by little. So this time I should be able, okay, the number still works. Run again. A single character, like an and, should work. Okay. And then I'm going to bump out, run again. And let's say that I enter in not just one character, but multiple. So it says you didn't enter in a number. Enter in a number. Okay, so this time it worked. You notice it didn't like keep repeating that like it did previously. And if I do it again, it's going to delete all that stuff from the keyboard buffer. And then it works. Okay, so this is how the best way to validate your input if it's a number. Now, one thing that can be confusing about this is that if you want to enter in a number in a range, so let's add that. Enter in a number between 1 and 100. And I'm going to add to my error message, you didn't enter in a number between 1 and 100. So previously, the way we would do that is we would have while num is less than 1 or num is greater than 100. Well, that's still how we're going to do it. We're just going to add that logic to this expression that we already have. So it's going to check this still. But if that is true, basically if the error state is true, we'll get in this loop. Or, so it needs to be or, num is less than 1, is true, or num is greater than 100. So, and if you want to try to make this a little more readable, since there's a lot going on here, you can put these in parentheses, but you don't have to. This is just, I kind of like how that looks better. And so I'm going to save this. And let's see if I got that logic correct then. So recompile. Rerun. And so this time, enter in a number. So if I enter in a -6, you didn't enter it. So I'm in that validation loop right now. If I enter in a character or a string, a whole string of characters, that works. If I enter in 10,000, it should be a problem. If I enter 75, it works. Okay, so that's how you can do both, checking if it's in a range and checking the data type. Okay, one last thing that I want to show you in this video is something you entered in that. Okay, what if you want to say something like hit enter to continue? How would you create that logic? So right now, if I were to run this, compile and run it, it would say you entered, and then that number, hit enter to continue, run again. Like, it would just keep going to this line. But I want it to pause until the user hits just the enter key. So the way you can do that is with a function called get. And it's cn.get. And what that's going to do is it's going to get one character or space from the keyboard buffer. So it will sit there, since it's cn, it's going to sit there until it has something in the keyboard buffer. And then it's going to, and then it will continue with the program. So I just saved that, clear the screen, recompile. And so I am going to enter in a valid number. Now, you notice it didn't work. And that is because it's not that I did this line wrong. This is correct. But get works like getLine in that it reads white spaces. So whenever I entered 76 and the new line, that new line, remember, is left behind. And so I actually do need one cn.ignore before I do the cn.get. And so that's going to get that new line out of the buffer. And I'll say no there, clear the screen, recompile. And rerun. Now, it says hit enter to continue. Now that worked. So I'm going to show you that one more time. You entered 45. You see it's sitting there waiting on me. Hit enter to continue. Okay, I am going to hit the enter key right now, and it goes on. Okay, so that's kind of handy in some programs if you want to implement that. All right, that's it.